Hello everyone, welcome back to another interesting session of your CCNP and co-training. And in this part today, we are going to cover up your topic, which is like your implementing NET. So this is the section which we are going to cover in this part. This is the topic name is implementing NAT. So guys, this NAT stands for Network Address Translation. So before understanding this network address translation, we need to understand some basic things before going to the advanced configuration. So like as we all are aware of IP address, like what exactly your IP address is. So if you people will see, like when we are talking about the IP addresses, there are two types of IP addresses. Let's say the first we have is the public IP and the next we have is the private IP. So we will see the differences between both of the IP, either the private IP and public IP, because the total concept of your network address translation is based on your public IP or it is based on your private IP. So we will see the different points between the private IP and the public IP. So let's get started with the public IP first. So public IP is something, a kind of addresses which are used over the internet. So these IPs are used on internet. Whereas if we are talking about the private IPs, these IPs are used inside the LAN organizations. Like they are not recognizable over the internet. Whereas we can write not recognized on internet. So this is the first thing, that these IPs are not going to be recognized over the internet. And when it comes to the public IP, these IPs are recognized on internet. Like these IPs, we can say these IPs are routable over the internet, and we are making the communication today with the help of these public IPs only. So these IPs are given by the service providers, given by ISPs, and ISPs are going to get these range from the INA. So there are some specific ranges, and whereas these IPs can be given by the network administrator, given by network admin. So this is the first thing. And like these IPs are globally unique. And these IPs are, they are unique within the organizations. They are not globally unique within the organization. And you have to pay for these IPs. Like these IPs are paid addresses. You are not getting these IPs for free. But whereas when it comes to the private IP addresses, these addresses are free of cost. So you don't need to pay for these IP addresses, guys. So this is what basically the difference between your private IP and public IP, which we all are basically familiar of with. So when it comes to the ranges of the private IP, guys, so we have some classes here. So we have class A here, we have class B, we have class C. So there are some specific ranges for these particular IPs here. So if we are talking about the range of class A, so in the public private IP, the range for class A is 10.0.0.0 to 10.255.255.255, which means like if you are using class A IP in the private organization or in your local area networks, you can use this range of IP addresses. And if you are going to use the class B addresses, you are going to use 172.16.0.0 to 172.31.255.255. So this is the range which you are going to use in the class B. And when it comes to class C, you are going to use 192.168.10.0 and from 0.0 to 192.168.255.255. So this is basically the range which you are going to use in your private IPs. And apart from that, excluding these ranges, if you will get any IP, let's say if you got some IPs, like if you got some 12.0.0.1, if you got some 50.0.0.1. So these IPs are considered as your public IP, which are recognized over the internet. And with the help of these IPs, we are going to make sure that we are going to change make the communication from one network to another network with the help of these IPs. So how exactly the communication happens? So we will try to understand this by an example, that how exactly the network address translation works. So we will see, for example, if I'm talking about the working of network address translation, NAT. So let's understand some points about network address translation first of all. So it is a method of, translation of private IP. So we can say it's a translation of private IP to public IP, or we can say from public to private, public IP to private IP. So there was a reason like why this, network address translation was introduced. Like in order to communicate over the internet, we can write in order to communicate over the internet, we must have a registered public IP. We must have a registered public IP. So like, that it can be configured, like netting can be done on routers, firewalls, and servers. So if you guys will see here that how this network address translation works actually. Let's say this is my router one. Then this router one is connected to somewhat router two, and we have some switch here which is connected to this particular router, and here you have some devices, and here also you have some devices. Let's say this is your PC number 1.1 and this is your PC 1.2. So, and we have some gateway here like 192.168.1.100. And here you have some like let's say some public IP in between. So whenever this PC wants to communicate, let's say this PC 1.2 wants to communicate over this router 2, and here you have some, wide area network, and on this wide area network, there are various public servers like Google is there, Yahoo is there, and like there are lots of public servers over the internet. So if this PC 1.21 wants to communicate, so first of all, the IP 192.168.1.2, this is the IP of your LAN network device. Like this is the IP of your LAN network. Then it is going to go out of the network via this 192.168.1.100, the entry exit point, the default gateway. So you can write gateway here. So once the gateway will bypass the traffic on this interface. So here from this interface, like the IP will go on the ISP router with the help of some public IP, which is gonna be some whatever the IP you are using. So let's say with the help of public IP, because this public IP is going to be, routable over the internet. So in order to communicate over the internet, we must have a registered public IP. So with the help of this public IP, we will be able to make sure that we are able to browse the internet services. But if there is no public IP with us, so in that case, we will not be able to use the internet. So if I will be showing you, like, see, everyone has their own public IP. So if you guys will see, like I'm sharing my entire screen and I'm going and opening my Microsoft Edge here, and you will see I'm writing what is my IP. So you will see here I am getting 110.235.219.72. So this is basically my public IP. And if I will check my real IP, so I'll go in the CMD and I will write IP config. So here you can see in the Wi-Fi wireless LAN adapter, because I am connected to Wi-Fi here. So my IPv4 address is 192.168.1.36, which is my private IP. And this 1.1 is my default gateway, and this is my default subnet mask. So this is how, like, we are going to make sure the communication happens over the internet. So this is how the scenario works with network address translation, that it is going to convert the public IP to private and private to public. So the reason behind that network address translation, why the network address translation was, was developed. So, the major reason to develop the net was to save the shortage of IPv4 addresses. IPv4 addresses. So this is like the reason why we are going to, use the network address translation, because see, when it comes to the types of net, there are three types of network address translation. So the first we have is the static net. The second we have is the dynamic net. And the third we have is port address translation. Port address translation. So now guys, if you will see, like, what exactly the difference between static, dynamic and port address translation. So like the major thing is, like we are not going to discuss this static net, neither this dynamic net, but I will give you the introduction, like how they are different with each other. But in the lab session, we are going to discuss this port address translation, because like this is the only protocol which is being used, like, this is the only type of net which is used in the production networks, and we are only using this PAT only. So now if you will see guys, when it comes to the static net, so this static net means like one-to-one mapping needs to be done manually. One-to-one mapping, and that too is manually. And the same thing is with the dynamic net, like one-to-one mapping is also there, but it's not manually, it's automatically, like we can say dynamically. And when it comes to port address translation, so like port address translation is something, like where we can say this is the most important part. So let's discuss this port address translation in detail. So which means thousand of users can connect with one public IP, can connect with one single public IP. So this is basically, the reason which we are going to see here, like why we are going to use the port address translation, because it uses the port numbers which are mapped to the single public IP to the different connections. And port address translation is the real reason why we are not running out of the IPv4 addresses. So let's try to differentiate between static dynamic NAT here in this scenario. So for example, let's say you are working in any organization. Let's say this is your organization. So in your organization, let's say you are having some 5 devices. So let's say this is your private IP, and this side we have your public IP. So this is the scenario which we are talking about, your static net. Static net, and we are talking about the dynamic net. Now you will see the differences between static and dynamic. So for example, you have some private IPs. Let's say you are using some A class 10.0.0.1, 10.0.0.2, 10.0.0.3. So in that case, you have to be, use some public IP. So for example, in that case, you need one public IP, let's say 50.1.1.1, 50.1.1.1.2, and here 15.1.1.1.3. Now, this is what the real reason, like we are not using the static and dynamic net, because, guys, for example, let's say in your organization, if you are working and you have some 250 devices in your organization, like 250 client machines are there. So in the case of static and dynamic net, every single private IP needs to be mapped with one public IP, which means like if you want to browse the internet, so you need to purchase one public IP, and that is like paid IP. That is a kind of expensive solution, like which we cannot, maintain. And like apart from that, if you are going to maintain, that's not relevant as well, because every user needs one single public IP. So that's really not relevant in today's solution. So in spite of that, what we have introduced is we have introduced the concept of dynamic net. And in case of dynamic net, what is the scenario? Let's write here dynamic net. Sorry, not in the dynamic net. This is your port address translation I'm talking about. This is PAT, port address translation. For example, if you have 10.0.0.1, if you have 10.0.0.2, if you have 10.0.0.3. So these are the public IPs, which are private IPs, which you are using. So all the IPs can communicate with one public IP, 15.1.1. So you don't need to go and, purchase single public IPs for every of the device, and unlike like, your static and dynamic net. So this is why we are going to use the port address translation, that we can map as many as IPs with that particular machines inside our network. But whereas when it comes to static and dynamic net, all the mapping needs to be done manually. Like every IP needs to communicate with one single public IP. So for every private IP, there should be one registered public IP in case of static and dynamic net. But whereas in port address translation, we don't need that scenario. So we will see a quick lab scenario with the help of the same diagram, and I will also show you how we are going to configure the static net, and then how the static dynamic and port address translations are different with each other. So this is how like basically the network address translation works, and rest of the part we are going to see in the lab session.